let's turn the music down a little bit. Well, that appears to be off. Nope, there we go. And get this stream underway. Today's stream is going to be calm and casual because I'm not in the best mood in the world. I just want to see if I can get some work done, feel calm and better about the day, about myself, all that good stuff, you know. It's gonna be good. It's gonna be good, and we're gonna work on extruding curves along curves so that we can make 3D volumes right away. So I'm gonna focus on extruding, well actually let's think about this for a minute. What's the best way to do it? Let's do okay, so we got a Bezier patch, that's great. But let's go here, extrude along planar. Let's do path extrusion. So we'll do deafen extrude. Let's start with extruding a curve along a curve. We'll extrude extrude curve along curve. So we've got the cross-section curve function, and then we've got the path, both of which are parametric curve functions. So let's begin path extrusion by assuming the path curve is planar, which is simply done by only using 2D curves, which implies that the curve is along the XY plane. We'll start with that because that gives us, that solves one problem with orientation. Excuse me. Oof. Okay, so let's make a path, okay, and we'll do just do a Bezier with 4 control points. Okay, we'll start it at 0, 0. We'll end it at, ooh, let's do 400, 0. And then here we'll do we'll do it like that. Oop. Something like that should be good. And what I'd like to do is produce, oh, let's close this off there. So let's do bit. Let me check first of all. Polyline. Yeah. We'll do like this. Def path points is just going to be map path, this function here. Yeah, map path over range 0 to 1. That should be good enough. And now here we can do, oh, actually, we'll do that, path polyline, and then we're just gonna do fm/polyline that, like this. And then here we just spit to the pottery SCAD file, because that's what's being displayed here. SCAD/write path polyline. That should, there we go. So now that is the path we're going to be extruding our shape along. So well, let's think about this just for a second. So what we want to do is so if we assume, let's build in some assumptions to build out the easier approach first. So we're going to assume that the path curve is planar and on XY. We'll require that. Let's also, should we also require that the other curve be what am I saying? If we assume that the curve is also planar, the curve that we are going to extrude, then we can transform it. Should we transform it? It should be basically what I want is to have the y coordinate of some assumptions to start with something easy. Path is planar in XY, and XS is planar in XY. But first, so okay, so always point local Y in global Z direction, and XY, and sorry, let's do 0, 0 is centered at the path. Right, so given any that kind of works. So what we want to do here basically is convert do I have a rotation function? I can't remember. If I rotate a point, let's say it's 1, 1, 0, and I just want to rotate it I'm just trying to do the geometry in my head here. All I'm trying to do is extrude something along a curve, and it's two planar curves, and I'm just trying to figure out what the right transformation assumptions are to get it all positioned properly, at least initially. Right, so basically I have to transform the plane pointing Y up, so that always means you're rotating your two rotations. Your first rotation is going to be what's the rotation? Is it ZXY or ZYX? I can't remember. XYZ. So let's see. 90, 0, 0. So we're at now, I've rotated a point at 1, 1, 90 degrees about the X, which means Y is 0, which is correct because I'm on this plane now. Okay, so that makes sense. Okay, so that seems like the first, that seems like a good step. We're just gonna kind of build this up from here. I know there are ways, I'm sure there are optimizations and better ways to think about this, but I'm gonna build it up from something I can think of and then figure out this stuff to improve as I go. Sorry, it's my grandma's birthday. I'm just checking in that things are going well. All right. Okay. Let's continue this thought process. Where am I at here? Oh yeah, here we go. So let's do this. So first of all, we're turning two paths into, it's going to be a surface of some kind. So we have to return a function taking in u and v coordinates. We're going to assume the paths are open at the moment, so I'm not going to try wrap UVs around on themselves or anything. I can work on that later on, because what I think I'll really want to do is have general functions that can detect if a 2D curve or whatever, if it's closed by checking 0 and 1 positions. If their distance is less than a delta, then assume that it's a closed surface. But I'll build on that idea later. For now, we're gonna just go forward with this and see what we can do. Basically what I want here is V is going to be, given the assumptions I've kind of built into this, I want the u coordinate to be the position along the path, and the v coordinate to be the position along the cross section. So let's write that down here just so I don't lose track of that. U is position along path. V is position along cross section. So given that bit of information, what we have to do basically is we're gonna let the starting point, because that's what happens here. For any UV, it just returns a 3D point. That's really all it is. Super, extremely simple. So what we do here is we get the starting point, which we want it to be off the cross section. So it's going to be cross section. Why did my screen go away? Sorry about that. That was weird. Looks like it's back up and working okay now, at least. I'll take that. I don't know why that happened. Strange. But anyway. So what did I say here? V is position along XS, the cross section. So we make the point to be this. So now the point this is going to give us, because we're assuming that both curves are planar, it's going to give us an XY point, which is not right. We need it to be three-dimensional. So what we're going to actually do is conj, let me make sure this is right. Yeah. Conj 0 on there, so that turns it 3D. But what we actually have to do is create an X point, which is going to be point threaded through a few things here. So we're going to actually rotate point, the point, and we're going to rotate it 0, 0. No, sorry, pardon me. We're actually going to rotate it 90, 0, 0. Okay, so that rotates it so that Y is zeroed out, right? It's point, so that the plane is now pointing upward. So we've translated the XY plane, and now it's the XZ plane. The next thing we need to do is actually orient the plane. We need to apply some angle rotation about Z to point it to the correct position along this curve. So what we actually need to do here is produce some new Z angle, which is going to be derived from, well, how are we going to figure this out? First of all, at this point, we need to find the path point in X Let me think about this just for a second. So we need to find the okay. It's not the tangent, it's the, or it's not the normal, it's the, where did I put this? Well, let's just make a new function. It's the curve forward direction is what I want to call it. So, let me see, 0, 0, 1, 1, negative 1. Okay. Right, so here, let's do this. Define curve. What's, what do I want to call that? Curve tangent, I guess, is the right. So it's going to be curve, and it's going to be a t value for that curve. Yeah, that is correct. So let's do let eps be 0.0001, 0.0001, like that. Okay, so what's the right way to name these things? A, B, yeah, that's fine. So let's do A is curve at t minus eps, then B is curve t plus eps like that. Yeah, that's fine. So then, so we're just gonna do then we're gonna do normalize let's do it like this. Thread first. SU V minus BA. Then V plus curve T. Am I doing this right? That won't matter, will it? Normalizing it'll make it the same again. I think I don't need to do that. I think I just need to do this. I think that's right. So let's try it. So let's do, we've got path 0.2. Yeah. So if I do curve tangent at path 0.2, it does give a result. Okay, that's good. Let me sanity check myself here. I don't think this will make a difference, but uh-oh. It does. I think this is wrong though. Okay, I clearly have to. First of all, let's assume that this is correct. If it's not, I'll know quickly enough and then I can work on it. But let's start with that as a basis for assuming it can work. All I need to do, if I assume that that points in the right direction. Oof, sorry, we got a flashy screen here. There we go. That's fixed. Let's do right. Okay. So this is correct here. we'll go with that. All I need is to figure out the angle, right, is angle from points. So the first point it's gonna be path tangent is curve tangent of path at V, no, at U. Then Z angle is actually going to be SU angle from points, and the points are going to be path tangent 0, 0 and 1, 0, like that. Now this should just be rotate 0 Z angle, like that. So that should be the new X point. Hopefully that's right. Then you actually just return X point, right? Ooh. Rotate point comes from forge utilities, like this. FU. There we go. Okay, so let's give that a shot. I don't expect it to totally work, but I mean, we'll see. Right, so all I need to do here is open surface 20 over something. So let's do, you've got path. Let's do def cross section as let's make it a much smaller Bezier, like this. 0, 0. It's actually, let's make it negative 20, positive 20, like that. Negative 5, 30. 15, 20, and then we'll make this be XS polyline, like that. Let's see. Did that not work? Something went wrong here, I think. Oop. Okay, well, I'm gonna go to the bathroom. I'll be right back. Not sure what happened here. Oh, this is why. We got to do this. What have I done? Okay. That's XS. Let me check here. Can I just do... Is that a thing? Does that work? Oh, it does. Perfect. Okay. So those are the two things I'm working with here. Let's see what happens when I do. Let's build this extruded curve like this. Extrude curve along curve, XS path, and we just do open surface, just do 20. Okay, it didn't break so far, but maybe it will on render, but let's see what happens. So let's also map this here like this. Okay, so we have something, and it's sort of resembling the right thing, but it's clearly wrong. So, oh, here's something I absolutely forgot to do. I do also need to translate this thing. I need to translate the plane to the position to the path point position, which is going to be conj path u 0 like this. So I need both of those points, and then I need to do, is translate point a thing? It doesn't need to be, because all I need to do is actually this. I need to do I think that should actually cover it. Let's see. Kinda. Okay, so I got my angle wrong. That's the thing. That's the thing. Let's swap this order like this. Close, kinda. Oh, I did it wrong again. I think I might have written it wrong the first time. No. Huh, okay. off by 98 degrees, I think. I'll have to figure out why in a minute, but let's just see if I'm thinking about it approximately correctly. Okay, so it starts off okay here, and then something goes wrong. Classic scenario. Okay. What have I done? What have I done? Let's do something silly for a minute. Oops, there. Wait, did that trigger properly? Okay, there we go. Alright, so here there's no rotation happening at all. Here, in this area, let's imagine that our direction here is, let's make up a vector that could be reasonably accurate. So, okay, so we'll set it up like this, angle from points. Let's do like a 5 and a 1, like that. Okay, so the angle's 11 degrees. If I do, okay, so if I rotate Z, first of all, am I rotating it the right way? It looks like I might actually have to do negative. Let's try that, negative. But now let's go like this, where the vector down is going to be sort of closer to, oh, I did this wrong. It should be a 1 and a 5 like this. This is closer to a 78. So the actual rotation I care about in this case is actually going to be, it is supposed to be 90 minus that. Yeah, like this. Okay, well let's see what this looks like without. Okay, so that's wrong. That was not right. Let's try it this way. Okay, so we've got the correct orientation for this part, and then it breaks here. Why would that be the case? Man. Well, so it's probably breaking at the point where the vector flips. Right? Let's see. Okay, so let's imagine now that we're closer on this side where the vector itself will point positive x and negative y like this. It should be a big number, except it's the same number. How is that possible? Why is that happening? That shouldn't happen. I thought I solved this, but I thought I fixed this. Ugh, that's frustrating. Okay, I don't know what happened. Is there but it also might cause problems. It might cause the surface to pinch in on itself. And I'm trying to think about a clever way to resolve that kind of a problem, and I don't know if there is a way to do that. That's the thing. That's the thing. Maybe 120 was a bit of an aggressive. What was the warning? Okay, that's theoretically fine. Wait, am I just wrong about? No, I'm not. Let's turn this off for a minute. It looks really nice. Nice smooth surface, actually. It's pretty cool. My head looks extremely purple right now. Why is that? Like a really pink. It's maybe a bit better. So the thing I'm trying to think about is how to handle a case where there are self-intersections along the way. I want to I don't know how I'm gonna do that in a way that's effective. But let me, before I okay, well, let's not let's not get bogged down with this stuff right now. What I think what I should do next is let's not worry about perfection yet. Let's figure out something let's make something useful and then go from there. I think that's a pretty reasonable approach. Seems like it anyway. So okay, let's change this up a little bit. Let's change the look of this. Let's make the path now, instead of this, let's actually make it let's see here. Sorry, I want to do 0, 0 like this, and then we'll do 300, 0, and then we'll do 300, 150, and then we'll do 150, 0. So that's a polygon. Then let's do p/fillet the points, and we'll do the points, and then the radius is going to be 20. Why is this wrong? That should be right. Oh, no. It's got to be like this. I'm doing this wrong. I don't want this polygon to exist yet. I want it to be just a point list like this. Then I can fillet points, and then p polygon. Then show 2D. That should work. What? Hey, how's it going, C Films? Glad you're doing great. Good to see you. let's see what we've got here. Oops, gotta do this. I'm not sure what I'm messing up here. How am I doing? How's the digital shape making going? Pretty good. So I'm working on extrusions along paths. So what you see here on in the visuals, let me clear this by the way. I was extruding one curve along another curve and testing that out in this 3D viewer. So that's coming along nicely. And I'm trying to make another path for it to extrude along. So I'm in the middle of trying to figure out what I've done wrong. I've made a mistake somewhere and I don't quite know what I've done. That's the only problem that I'm trying to sort out here. So we've got this, and then we've got, let's try that with a radius of 5. Okay, that worked. Oops, not what I meant to do. Yeah, okay, so that works. What's the deal, yo? Okay, well, let's define this path that I'm gonna extrude things along one step at a time, like this. Okay. Right, so this path, we're going to start it at 0, 0. Then we're going to go to 300, 0. Then we're going to go to 300, 150. And then we're going to go 150, 0. Okay, so that should work, I hope. Let's see what this looks like. What? Okay. Okay, let's do that. Let's test it without this. Let's see if we're on the right track with some of this anyway. Oh, okay, so I've made a mistake. This has to be like this. Let's try this again. There we go. There we go. Now we're getting somewhere. Kinda, anyway. Alright. Okay. Let's try this. See if this works. Yes, okay. Here we go. So I'm trying to just extrude things along paths. That's the name of the game. So let's try this again. Let's see if I can get this to work. Oh, that's not going to make a difference. Didn't work. Oh, this is also huge. Let's make this smaller again. Ah, okay. Why would X be null? Okay, where's this going wrong here? Oh, I think. Wait. Oh man, I don't know. Not having the most active brain day in the world, unfortunately. Rotate points not working. Hmm. Okay. I feel something, it seems, maybe I'm wrong, but it seems like I've got an issue with, well, oh, does it have to be, okay. I'm just gonna see if this solves, well, if this lets things compute. Okay. Huh. Okay. So I think I'm starting to understand where things are going wrong. If I do su slash angle from points, if I make this 0, 1, 0, 0, 0, 1, oh, curve tangent. What? Oops. Why is that going wrong? That makes sense. Yeah, okay, no, that's good. But why is curve tangent not working? Oh, does path negative 0 point... Ah, okay. Right, I made, let's see. Here's why it's breaking. It's because the path is strictly clamped from 0 to 1. So if let's see, how do I do that? Well, let's do the silly way. So if A, otherwise you do curve 0. Then B is just a check as well. So this is not very sustainable because there's a bunch of checks. I don't like that. So it's to prevent nils for now, but it's really not a smart approach. Honestly, it's not a good idea. But it should prevent nilling out everywhere. There we go. Okay, now we're getting somewhere. The obvious issues are the resolution's too low along those curves. I think. Well, before I get ahead of myself, let's see, is that true? Is the fillet resolution dependent? Let me check. I think it might be. Kind of, yeah. Okay, so that's no good. I think I might be able to kind of fix that by doing something to this effect. P/simplify by, let's make it so it's actually not simpler. There's a lot more points, but it might, not really. I mean, we're definitely getting somewhere. So here's the thing too, right? This is, it's not closing properly, which is that totally makes sense. I'm using an open surface approach instead of a closed surface. So there's no logic for stitching the ends together at all. So that's something that I have to add. There's this clipping at the end here because of that as well. Actually, if I change this to polyline, does it make a difference? It shouldn't really, but it might. Okay, yeah. That's a little interesting that it's passed, but okay, I won't worry about that for now. Let's see. This won't fix it either. Oop. Oop. What happens if I don't do anything? Like, what if I just keep it super simple like this? Ah, interesting. Oh, this has to close like that. Okay. Right, so we've got weirdness at the corners. Totally not surprising. I'll have to think about that, but I'm gonna go to the bathroom for a minute. There we go. Wrong button there for a second. Okay. Genuinely don't know how I want to start handling these kinds of considerations here. Like, I don't know what to do all the time. That's the thing. I don't know what to do. this. Circle. Let's try this, see what this looks like. Okay, that works. Seems pretty nice even. Probably have incorrectly overlapping triangles in this region somewhere, probably. Although maybe not. I'm actually curious if I do if I make the cross section also, well actually sorry, let me just do this, path. Oh, this is not gonna work. It's gonna have weird, I mean, I wonder if that's like a valid, or if there's gonna be degenerate things inside there. Surprised that it's actually trying to calculate something. I should have checked validity first. Probably it's not valid, but we'll see what happens. Ba-da-ba-ba-da-ba. I'm trying to think about what I should do next today. I'm just feeling, you know, tired and not totally focused on the work today. I'm just trying to think if there's like low-hanging fruit for generative meshes that would still be like, still let me do some really cool stuff. One idea I have actually that just came to mind is, oh, I know what I can start working on. I want to see if this will actually render, but while that's going, I can start to build out a concept for finding the curve of a boundary. I think that's a good approach. Excuse me. Oh boy. check something here. There we go. Yeah, okay, that works. Now let me just do the same with Polyline. Okay, so that's a line, that's a line. Ah, okay, so I do end up producing actually more spheres than I need. I should make this a more efficient thing, but nevertheless, I feel like this is not gonna work. Let's cancel this. I think I'm worrying about things I don't need to worry about right now. Let's build. Okay. Let's actually design, check validity. Nothing to validate. Oh. Interesting. Let's do, okay, before I get ahead of myself here, I've already gotten ahead of myself, I suppose. Before I move on, okay, let's make this a little more fun looking. I don't know what I'm talking about. Let's make this 40. Let's make here P/circle 20 instead. There we go. It's a little nicer looking. Sure, that'll work. Okay, right, now here's what I want to try to do. Let me come up with a, so let's put this Bezier patch back on here. Let's render that. I like the Bezier patch. It looks cool, looks fun and exciting. What I want to do is extract a parametric function that defines the curve along the outside of that, and I want to see if I can do that. Okay, so the bounding curve given a surface, right? I need to do I need to make it kind of a piecewise thing. So let's start with producing the simplest part, and that's just, let's just make it a function of t that produces given the surface, we're going to return the point given from the function surface. We're going to start with u, so it's going to be t, And then V is going to be set to 0 in this case. So let's start with that. Okay, so if I were to come up with let's just build a little group here. Oops, I don't need that. Like this, please. There we go. Oh, I have to do this as well. Okay, so if I do fm/polyline of the result of bounding curve on rectangle surface, that should give me, it won't be complete, but it'll give me one. Oh. Oh. This is wrong. Okay, so let's do def. These names are increasingly inaccurate, but deal with it. Yeah, okay. Here we do thread first. We'll take rectangle surface. We're going to run that through bounding curve. Then we're going to run that through map, that function through range 0 to 1 of 0.01. And then we run that through fm/polygon, polyline. Oh, really? Oh, here, this is why. A little bit annoying, but that's okay. We've got surf is this line. Wait a second. Am I in the right spot here? Oh, I'm not. Okay, sorry. I've messed something up. Actually, this shouldn't matter. Let's... Okay. Surf. Rectangle surface is surf thread through open surface 20. Here we go. Okay. Surf is this. Let's try this. There we go. Okay. Now we got something. Alright, now we're going. Now we're working on things. Let's try that again. Oh, the surface didn't... that's weird. Strange. Oh, there we go. It's really low res, but it's this here. Let's make this 70. Okay, there we go. Oh, this is getting weird there. Okay. Alright, there we go. So we're getting, that looks correct there. But what I'm curious about is how, well, first of all, the next thing I actually need to do is okay. Let's see. If I do 0.5 here, rerun this, and re-render, then it should place this line kind of halfway through this once it calculates. The surface is too many segments. Yeah, okay. Good. Kind of. It's mostly working. Right, so basically all I need to do is for the bounding curve function, it's going to be a piecewise function, and I'm going to run I was gonna say the bounding curve I could actually run pretty easily, but I'm realizing that's only true if I assume U and V map, like if there's not a degenerate condition. So you can use UV coordinates to map to a triangle-like patch, but that means that at one of the ends for all V, you've got a whole quarter of the curve that maps to the same point, so you kind of get a bit of degeneration going on there. So I kind of should build it into, well, let's not worry about it for the time being. Let's just deal with it, you know? Okay. So let me find remap. need a sort of piecewise curve function. And I need it basically to work like, well, let's see if I can find it. Let's go here, brep, Polygon. Let's try this. Oh, I've got, where's polyline? Let's try this. So there's this remap within thing that I need, basically. And it's going to work via let me check. Maybe it's better to look at the logic in the SVG, because I know here it's actually working for sure. Okay, let's go into parametric, Polygon. All right, here, this logic is what I need to build out a set of polygon. It's actually going to be piecewise curve. Instead of a list of points, we actually do a list of curves like this. Okay, and here now, right, so the intervals happen over shoot, this is where things immediately get complicated. Because the curves don't have the length necessarily computed. That's the thing. Bummer. I mean, I suppose for the initial piecewise curve situation, I can do something to the effect of length okay, so if I assume it's n curves, right? So the intervals are 0 to, let me see, the old logic will apply in this case. Let's see if this makes any sense. Okay. The step will be, okay, so if there's a polyline, 1, 2, 3, 4, the intervals to remap over are going to be, so the step size is going to be, count the number of points, 1, 2, 3, 4, so it's the third is the step. Lines and length, I'm just going to get rid of those because I don't need them in this case. So I'm clearing my brain a little bit. Points doesn't make sense. Right, so in this case, right, this was a polygon, so I was concatenating the first to the end to guarantee that they're closed. So what's actually happening is the step size is actually a quarter in that case, but it's not closed here. So I actually just want to count the curves, don't I? Because I don't want to decrement it. I think I want it to just be the count of curves is the number of steps in this case. Maybe even incremented, but I'll sort that out kind of later. That's fine for now, because that's the step. And then the intervals here are not length-based intervals. They're just going to be piece-by-piece intervals. So the what's that called? This spacing of t points on this boundary curve will not be consistent because I haven't built in length calculations yet. You need to be able to get the arc length or approximate the arc length to be able to redistribute the t values to be more even. So I'm not going to worry about that right now. I'm just going to do a basic thing here, which I can actually just copy this. Okay, so points is also not there. So intervals, I think this makes sense. If I calculate the step size as the count of the curves, 1 over the count of the curves, I think that should be okay. I hope so anyway. so this remap within function, I want to get, I'm pretty sure it's private, so I have to copy it into here for the temporary working of it. I do have this arc length estimation tool, but it's super slow because it uses a really small, it literally turns any curve into a really high number of straight lines and then gets the length of each line. So it's just slow. But you can't necessarily analytically solve for the perfect arc length given arbitrary curves. So I need some quick estimation if I want to do things lengthwise. So I'll think about that stuff later. I don't want to deal with it right now. That's the simple truth. Polyline has, yeah, see this remap within is private. So let's just be bad about it and just copy it in here. Okay, so we got piecewise curve. Let's see if that'll work. Lines doesn't exist. Oh, of course, because it has to be curves like this. Okay. Let's try. Function of t is a piecewise curve. Okay, so we just do piecewise curve, and then we pass in some curves. Okay. Wow, so simple. All right, so we're gonna start. Well, first of all, we're gonna assume that there's 4 curves to make the bounds. The problem with that is it's not necessarily true. There's a few ways to make a surface. For instance, you can make a surface with a single bounding curve if it's elliptical in nature, if it's continuous all along and starts back where it and ends where it started. It could be produced by 2 curves only, so it meets it, like they start at the same point and end at the same point, but they diverge in the middle. That's a valid way to make a surface. So I have to come up with a more general way to handle that, or create bounding curve functions for each of those cases, for all of the reasonable cases explicitly, and then have some kind of way to detect and then dispatch to the specific one based on the input surface. So maybe this ultimately means I need surfaces and curves to have a stable definition in my libraries, where for the zero arity function they return some pre-calculated values which can speed up computation of things. I don't know. I will have to think about it. Probably the smart thing to do, I don't know what the smart thing to do is. I'll have to think about it. That's the smart thing to do is really think about it, write down a bunch of assumptions, write down a bunch of problems, write down a bunch of potential solutions, and slowly evaluate and figure out the right approach. I'm more and more convinced that the right idea is something like this, where parametric curves and parametric surfaces and even parametric volumes have, per definition in my library, my 2 libraries, SVG and my Forge library, they require a zero arity call where they return a map of a few required data points and a few required calculations. So length, area, the curves that made it up if it was a bounding surface. And I have to figure out the things that actually make sense to put in there so that the functions don't get massive for so that moving them around in memory can be quick. These are all things I have to figure out, but I'm quite sure this approach is actually kind of a good idea because it is helpful for quickly calculating things like lengths if in the original construction of the curve I need to calculate elements of it anyway. So that means as I build up more and more complicated and arbitrary combinations, every step of the way I am using values that were computed anyway in the building of the function and just storing them in the data structure. I feel like that's a good way to do it. It's almost like caching things that you've computed anyway, so you don't constantly have to recompute, and so you don't, in most cases, have to compute complicated things which were simple to the components but just combine in more and more complicated ways. It's like a crude idea of automatic forward differentiation where you kind of use dual numbers to sort of keep computed stuff that's relevant in the number or data being passed along the transformations. I don't know if that's a fair comparison, but that was like popped up in my head. Maybe it is. I don't know. Okay, blah, 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 blah. Let's just get this piecewise curve business working, hopefully, and go from there. Okay, so assuming a 4 curve bound, which, by the way, is... I'm going to use this Bezier patch as my canonical surface to check with. Once this loads, it'll show the Bez patch. Okay, so what I want is to run and display the bounds and it to show a curve here, 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 and here. And in order to do that, I just have to run. First of all, I'm going to go from U0 to U1 for V0. So I do T0 here. The next curve is going to be at U is equal to 1 in this position. So I just make U set to 1 and then I have T be the variable here, going like this. Then, I have to do, because I have to go backwards. Let me think about this for a second. That should be fine, right? If I just do 1 minus t, that'll flip it. I think that'll work. Right, so this curve, this one has to be inverted. So I have to start at V is set to 1. That's fine. But U is actually going to be 1 minus t like this. And then here we set U 0. And then we go V is going to be 1 minus t here. Okay. Is it going to work? We'll find out soon enough. All right, let's do this on the Bezier patch here. patch surface is just going to be run patch through open surface 40. Okay. But now then I just have to get rid of this line, which means I don't have to thread this. It's not being threaded through anything. The reason I'm doing that is so that I can run the patch through, make a patch surface, and also make a patch boundary by running patch through oh, let's close this, by the way. Bounding curve, which will look like this. Okay, so let's try this. Oops. Okay. And now we try fm/group patch surf and patch boundary and see if that works. Does not work. Okay. Does it work if I do this? If I get rid of the patch boundary? Oops. Let me just sanity check that this works. Okay, that's working. Okay, so patch boundary is not. Let's go fix it. Let's get rid of these two. Let's just start with, let's try to get something working kind of anyway. Oh, never mind. Before I go that route, I didn't finish rendering this properly. I keep forgetting that I haven't built automatic helpers to render continuous curves without, like, I have to still manually run it through. Where am I at here? Okay, path extrusion. Right, so this is not, this patch boundary, I can't render that yet because I have to do run the patch through the bounding curve, and then that function I have to run through map range 0 to 1, 0.01, and then fm/polygon that, and that should hopefully oh. Oh yeah. It's got to be a list of curves like that. All right, let's try this again. No. Oh. Okay. Oh, I should be able to do it like this. Oh, that's wrong. Of course. No. This is right. I shouldn't need to do anything more than that. No, that's not right. This, let curve be this piecewise curve. Right, and then I have to run C of t. Wait a minute. Is that even right? Am I even... Yeah, I think that is right. Okay, let's figure this part out. Okay, so if I do patch boundary, key must be integer. Remap within is not working. Okay. Okay. Slow brain day, slow brain, slow brain. Okay, I'm thinking about things slightly wrong here, aren't I? I need... I don't actually want to pass t in here. I want these to be like this. Don't I? I think so. Let's see if that makes any sense. Okay, so let's try patch boundary. There we go. Ooh, almost. But why is it nil at 1? What did I mess up? I messed something up. Although, let me see. Wait, does it break at 0? No, that's fine. It's almost right. It's almost correct, but there's something wrong. At why is that? Okay, well, let's do this. Let's put the cond in there to guarantee continuity at 1 and 0, and then we'll build out a better solution as time goes on. Okay. Good. Okay. If float 0, if float t is 0, then you actually just run first of curves t, well, 0, like this. And then here you run t. Well, let's make it. Actually, I don't need to. No, this should be fine. You run last curves like this. Okay, let's try that. All right, let's see if we can get this to work now. Yes, okay, maybe. Huh. I guess not quite. Let's see. Something went wrong. Paths. Oh. Maybe? There we go. There we go. Okay. I've not completely lost my marbles. That's a good thing. Whew. Okay. It's pretty cool. I mean, it's okay. It's better than nothing, right? Alright, that's gonna be enough for me for the day. It's been slow going, but got some good stuff done. I got the beginnings of an curve extrusion. I've got some path boundary calculations kind of working anyway. It does look like the remapping is working acceptably. It's just not closed here, and that's fine. That's no big deal. It's following the boundary of the curve just fine, so that's a good thing. Feeling okay about this. Honestly, it's not bad so far. Not bad at all. Next thing, actually. Let me see if I can... Oh, before I go, now that this is at least provisionally working, let me try to do the extrude surface thing. Okay. Right, so we've got here bounding curve, extrude surface at least can be something like let bounds curve, right, be bounding curve. I don't even need to do that. Let's just let the bottom surface is just going to be okay, so I'm gonna make a provisional visually acceptable thing here, and then I'm gonna call the stream done for the day. I'm realizing basically I'm gonna have a bottom surface, a top surface, and then a extruded surface based on the boundary. And then I'm gonna have to find a way to merge those triangulations into a single thing. But instead of doing that, oh wait a second, no, I realize, never mind. Well, okay, I'll make it this provisional thing. Okay, so B, let's extrude the surface to the height h with segment count seg. And here I just have to run open surface on surface with seg, like that. That's the bottom. And then the top, I'm going to just do a crude thing here where I just take a copy of the bottom and translate it up the height. So fm/translate 00h, and that's the top. Then the mid is just going to be I have extrude curve 3D. That's what I want to do. Right? Let me check. extrude curve 3D of bounding curve of surface. Okay, now here's the provisional thing. I'm just going to group bottom, top, mid. Okay, let's try this out. Let's take this Bezier patch. Okay, and for a moment here, let's just hide this and just do extrude surface of the patch by a height of 50. Okay. With I think I missed something. Z. I need a Z height, of course. That's a little silly of me. Extrude curve 3D. Here. That's the curve. You have the height Z like that. Okay, let's try this again. Okay, we at least we're getting somewhere. Okay. Now what's wrong with this? Extrude curve 3D. It is for sure a 3D curve. I'd like to extrude it, please. Let's do this. Oh, right. Here we go. In here, this I have to do like this. Bounding curve of surface. Map that through extrude curve 3D to height. And then make it a surface. No. I'm going to make it an open surface, but it is supposed to be a closed surface, but that's fine. I will deal with it. Which takes seg. There we go. Okay, there we go. All right. Almost there. Almost have something. That is looking pretty good. It's definitely not right, or it's definitely not a complete solution, and the reason is because I have, well, if I turn on edges, first of all, you can see that the steps along the boundary curve do not match the steps on the surface here. In fact, they'll be 4 times off, and the reason for that is because this curve it's piecewise. It was remapped with 4 curves, so every T step is going to be off by a factor of 4. So what I actually should do is do here. This should actually be seg times 4. And that should then actually line those up. Indeed it does. And I actually wonder, now that I think about this, if it'll be if it'll compute. There, no, it's not closed. That's fine. I didn't really expect it to work. That's not what I meant. There we go. Okay. So, oh yes, of course. Here's the other thing, right? This bottom surface is oriented incorrectly. So I have to actually create a function that, so I don't want to, I want the surface to stay the way it is. I just need all of the triangles to invert. And all that means is the winding order of the triangles has to flip the other way. So I will need a function for flipping, right? So I'll need defin flip surface. No, that's yeah, flip surface orientation. So given a surface, no, do I want it? Okay, so for this to work, all I actually need to do is get the faces, and then per face, if so the winding order is 1, 2, 3. I actually just need to, all I need to do is swap the last two. Well, I actually just need to reorder any. So I can't cycle it, that won't do it. I have to swap the second and the first, like that. That would work. Or the last two, that would also work. Or first and last. Swap first. Wait. Oh, I could just run reverse on him. Yikes, man. 0 to 31. 31 to 1. 1 to 0. Yeah, I literally just reverse faces. Jeez. Okay, that's not that hard. So let's see. Given an open surface, let's just make a little interior function for that. What's the structure of this? I forget. Okay, so given a polyhedron, get in 0, 1, get in 1 faces, update faces with update in with map. I think this will work. I hope so. Map function face vec is that gonna be right? Let's see. Whoa, that actually worked. Yeah. Oh. But it... Wait a minute, why did that happen? Oh yeah, of course. So that... Alright, let's see. Okay. B is update in S tries. This whole thing. And then T is S tries. There we go. Okay. Now let's run this. And I am curious if that will actually make the shape valid. Because if it does, it's pretty cool. Not closed. Okay, so I still have to work on no yeah, I got you. Right, so I will have to still work on. It's almost there. I have to work on a few things. One, closing, making sure things close here properly. Two, actually merging the triangle and point lists. So that things don't totally flop, and just sort of figuring it out from there. Well, yeah, that's gonna be it. So yeah, thanks for tuning in. Should be back tomorrow, hopefully. But I gotta get going. All right, bye-bye.